All right, noble gas notation. It says the noble gas elements are group what? What group are they on the periodic table? What family number? We wrote it on our periodic tables in our journal. So which group number has our noble gases? 18 is correct. Good. So we're going to go ahead and say group 18. Okay. And they have blank valence electrons. So if you pay attention to the tops of your periodic table, remember we learned about valence electrons are kind of shown. An easy way to remember them is the ones that are attached to the A. So if we look at group 18, we have 8A. So that tells us 8 valence electrons, all right? And today, and hopefully in this lab, we're going to be, oh my gosh, not 8A. We're going to see where that 8 is actually coming from, okay? All right, so they have 8 valence electrons, which are electrons in the outer energy level. Your exception to that is obviously helium. Helium only has 2. Okay? All right. So your noble gas notation is going to allow us, so it allows us to write electron configuration for lower, I'm going to say lower elements. It could have been outer or more complicated elements. But what I mean by lower is that on your periodic table, the ones that are below energy level number 4. Okay, so the higher energy levels down here, those are the ones that get kind of complicated. So we tend to use noble gas notation so that we don't have to write that entire electron configuration like this, right? This is an example of europium. Wouldn't it be nice to just take all of that away and just have 6s2? Yeah, right? So that's what we do. Okay. I'm realizing that's not actually what it would have been, but that's okay. We'll move on. So, but we're going to write these elements that are lower on the periodic table in a simpler form. Okay, so it's kind of like short. Some people call it shorthand notation. You'll be hearing me call it noble gas notation as much as I can. Hey, Roger, make sure you're writing notes. Okay, so it uses the noble gas from the previous energy level. And then the electron configuration of the outer shell. Okay, so we are going to take a look at the first example, which is given to you, which is sodium, right? So everybody make sure you find sodium on your periodic table, put your finger on it. So it's going to be important for the next step. So find sodium on our periodic table. So here's my periodic table. Sodium is right here, right? So typically the electron configuration was 1s2, 2s2, go across 2p6, and then 3s1 is where it's ending, right? We see that? So in order to write this noble gas notation, we're going to hit the noble gas from the previous energy level. So what that means for you is you have your finger on sodium, go up an energy level, all the way to the right, and what did I land on? Who is that? So go up an energy level, all the way to the right. That is neon. Good. So we're going to start with neon, and we're going to put it in brackets. And so what this is telling you is all the electron configuration of neon, okay? And then you're going to continue your electron configuration after. So we got neon, and then we end at 3s1. And that is the noble gas notation. And that's it. So a lot shorter, right? So you can see the benefit when you get to the lower elements on the periodic table that have these long, elaborate electron configurations. This shortens it up. What you see that we got rid of was 1s2, 2s2, 2p6, right? That was neon. All of that was represented with this little bracket part. And then we were able to get rid of it, and we were left with 3s1, and that's it. Okay? So you basically will go to that noble gas and then continue the electron configuration as if it was normal. Okay? All right. The reason it works is due to the Aufbau principle. Okay? The Aufbau principle, that was a funny name from your POGIL, okay? You had to learn about all the different rules that the manager had. One of them was that you had to fill up the first floor first, then the second floor, then the third floor. That's Aufbau principle. You start with the first energy, you start at the top of your periodic table, and you have to go in order. And you have to fill up S before P, right? So for us, that's moving through the periodic table in order. All right, so orbitals are filled in order from lowest energy levels to highest energy levels. Okay, lowest energy levels to highest energy levels. All right, so we're going to take a quick pause break on that. I'm going to hand out your page that we're going to practice on for about 10 minutes, and then we're going to come back to this and we'll talk about ions right after, okay?